Today, my fellow scientists Zoe and I have chosen to focus our big story primarily through the means of gravity and its contribution on specific biochemical and biological processes, as well as material composition within the universe. We've chosen to incorporate temperature and various forms of energy, followed by ultra-cold neutrons and gravitational potentials. We close with the chameleon theory describing gravitational behavior and its place in the expansion of the universe. The inflationary model is the rapid expansion that started at a single point, that is continuously expanding exponentially. The first star explosion forms secondary stars. The large mass of materials colliding together creates heat and releases reactionary terms and heat energy. Collisions cause massive amounts of heat energy to transfer and eventually cool, forming planets combining with gravity.
The formation of the universe is composed of dust and gas colliding together in space, most likely caused by a supernova explosion 13.7 billion years ago, which is also called the inflationary model of expansion. The forces of gravity pulling continuously cause debris and dust to collide, transferring energy, stopping the momentum, and eventually spinning, forming rocky surfaces like ours and others in the solar system. This is also how rings form around the planets like Saturn. The rings themselves even have their own gravitational forces. What would happen without gravity? Everything not bolted down would be streaming projectiles into space, and the atmosphere itself will disassemble as well. Everything bolted down will fly away in a few minutes. The Earth's core would dismantle itself and lose all stability. What would happen to our bodies without gravity? In the long term, your body needs gravity to pump blood through your body properly. Our bone density depends on gravity as well as muscle mass, red blood cells, balance, and sleep. In the short term, it wouldn't matter. Within 15 seconds, the liquid in your internal organs would fill with outside air, which scientifically is called an embolism, and it would cause unbearable pain. We would pass out immediately and die quickly from lack of oxygen. Holding your breath would only cause your internal organs to rupture and basically kill you from the inside quicker.
This would be the primary issue if the sun were to suddenly disappear. Gravity is a property of matter. The sun, being around 330,000 times the mass of the Earth, keeps it in its orbit. At this point, Earth would project out into a straight line tangent to the position of its orbit. If the sun were suddenly to disappear, we would not notice for about 8 minutes and 20 seconds. In regard to the sun and heat, certain biochemical processes would cease immediately, one including photosynthesis.
Running in normal gravity and lessened gravity is very different than expected. It changes the way your body moves and functions. Lessened gravity surprisingly exerts more energy in order to accomplish the same goal as current gravity. Your body would have to work harder in order to get to the same places and require movements of previously unused muscles to do so. The videos shown are how you should move to maximize your energy when running or jogging. You can see here Usain Bolt trying to run in lessened gravity, obviously having issues since he can't get the same traction, and it seems he is trying to run in the same way he would in increased gravity. He seems to have lost to the other men who have had experience running in this type of gravity.
A large collision of matter occurred about 66 million years ago when the asteroid hit and exterminated the existing species, what we would know as dinosaurs. This asteroid warmed the Earth for 100,000 years, which eventually cooled to about 26 degrees Fahrenheit. Gravity plays a crucial role here as geothermal energy in Earth's inner core is contained from the inside out. Without gravity, Earth's core would disassemble and geothermal processes would be severely altered.
Core cooling. Temperature dependency on gravity and acceleration is influenced by external forces. The subject decreases the attractive forces while decreasing their temperatures. If the average temperature of a planet becomes too low, the gravitational forces it shares with the sun increase, which I believe means you would start spinning faster. If that's the case, we would most likely get pulled closer to the sun at the same time, either causing us to burn too close to the atmosphere or heat the planet up too much for humans to have it. The same reactions are believed to happen with plasma in the vicinity of the sun, causing it to have less gravitational magnitude because it's warmer.
Transfer of heat by means of electromagnetic waves through space. This heat transfer allows habitable temperatures on Earth. This also applies to other objects in the universe where heat energy is transferred between massive objects. Temperature, being a measure of the average kinetic energy of the molecules of a substance, plays its role here. The universe is in a gradual state of cooling and expansion. This happens between stars, Earth's core, etc. These are all cooling gradually.
An experiment was done on ultra-cold neutrons in a gravitational potential well. They were poured in a continuous stream into a mirror with an absorber like this picture shown above. It was expected the particles move in a pattern similar to the picture on the bottom, but they did not. Instead of moving like the pattern at the top of this picture, they moved similar to the pattern in the bottom, continuously. If it had enough room, it would have continued. Outcome was unexpected, and the scientists have theories, but they are unable to prove them right now.
The sun formed about 4.5 billion years ago. Its position of about 93 million miles away from Earth made it to where the light and heat energy could provide a suitable environment for algae to thrive. An abundance of nitrogen catalyzed algae to bloom, which in turn gave off the first oxygen on Earth. We know photosynthesis and the sun's role in that process, along with water, nutrients, and other gases, gave a byproduct, which is glucose and oxygen. The sun and oxygen are essential to humans as it is to plants. Byproducts of photosynthesis are oxygen and glucose. Byproducts of respiration is carbon dioxide. We see in turn that both need each other. One man's trash is another man's treasure, as you would say. In turn, this represents a symbiotic relationship. Oxygen is essential to the aerobic process called respiration, beginning in the mitochondria of the cell. Respiration is what allows the body's cells to break down sugars or glucose for energy. This can only happen when oxygen is present.
One interesting theory about the universe is dark energy and matter. The universe is made up of 25% dark matter, 70% dark energy, and 5% matter. Although we don't know what dark energy and matter are, we know they exist due to the absence of light materials within the universe taking up other space. They are not black holes affecting things in their surrounding area because it's all over the place and interacts with gravity. Dark energy is energy of empty space in the ever-expanding universe. The empty space's energy is constantly growing as the universe expands. Picture showed is a map of a cosmic microwave background of the observable universe. Although there are still many theories surrounding dark energy and matter, nothing is confirmed. You can see here the different lights in the galaxy when they tried to form this experiment.
Wrapping things up, gravity holds material together. In the grand scheme of our creation, it holds together material which planets and stars are composed of, which reflects the composition of various types of matter. Gravity allows biological and biochemical processes to take place. Core temperature, atmosphere, and radiation all in part are derived by gravity. Gravity works in correspondence with energy in pulling matter together. Opposing forces with dark energy and matter give way to forces that deny and pull matter apart. Gravity is critical for us and for the universe and contributional to our big story here on Earth.